Hello and welcome back to the second video that I put together with this guided tour around the National Museum of the United States Air Force here in Dayton, Ohio. I ended up recording a lot more footage than planned, so this is why there's a second video. In the first video, we looked at the early years, World War I and II, the Korean and Vietnam Wars. In this video, we're looking at the Cold War, exploring the Research and Developmental Gallery, presidential aircraft, ICBMs, and much more. It'll be another long video, so let's get into it. And we begin with what I was most excited to see here, the Northrop Grumman B-2 Spirit, also known as the stealth bomber. Much of this remains classified, and this aircraft was a prototype used for structural testing. In fact, it has a large crack under the starboard wing, which has been covered with a few metal patches, which are hard to make out as my camera struggles in the low light. There's no other B-2s on display anywhere in the world, really highlighting how special this place is for an av geek. What's most noticeable about this aircraft in the metal is just how large it is. It's also incredibly smooth. In fact, it's hard to film as it just looks like a giant triangular blob. In fact, there are no breaks in the surface, and you may have noticed several small lighter coloured circles, and these are the instruments that detect airspeed, amongst other things, and replace the traditional metal pitot tubes that would otherwise have a high radar return. Its 4 turbofan engines are buried deep inside the fuselage to help reduce the heat and noise signatures and keep the fan blades away from enemy radars. There's a whole array of fascinating design features that I talk about in a separate B-2 video that's on my channel. These are capable of carrying both traditional and multiple nuclear bombs, as you can see here on display under the port side. The first two are B-83 and B-61 thermonuclear bombs, while the third is a conventional GBU-3132 JDAM guided bomb. It's really interesting comparing the size of these bomb replicas to what you've seen next to the B-29 earlier in the video. Moving backwards in time, we walk towards the SR-71 Blackbird, and we have the D-21B drone. After an agreement to not use manned flights over Soviet territory, the Americans hoped to get around that by using remote-controlled drones, and in the 1960s, this was developed by the Lockheed Skunk Works department. It would fly up to 95,000 feet on reconnaissance missions, and it was powered by a ramjet engine, which is unique in that it's powerful and efficient, but can't operate at low speeds because it relies on incoming supersonic speed to act as a compressor. So they attached it to the top of an A-12 derivative, the M21, with M standing for mother and D standing for daughter. This program was not a success. In fact, there was one crash after the drone hit the mothership as it detached, killing one crew member. The drone was modified to be launched by a B-52, although these would be flying much slower, so a secondary rocket booster was attached to get it up to speed, and then the ramjet would take over. There were several flights over China, and some were successful, although there was also engine failures, and one accidentally dropped off a B-52 due to a stripped nut. The one remaining M1 mothership is on display at the Museum of Flight in Seattle, and I'll mention that in my video from there, which I hope to finish editing soon. Looking forward, at that big dark blob, is the tail end of the B-2 Spirit. It really is a fascinating design how they've managed to use the wing's trailing edges control surfaces to replace everything that the empennage would usually do. The exhaust is released above the wing and well forward of the trailing edge to give it a chance to cool down, thus reducing the heat signature detected from below. Spinning around, and we have the F-16A Fighting Falcon flown by the Thunderbird display team. This aircraft evolved from the 1972 lightweight fighter program, which wanted a small, light, low-cost air superiority day fighter. This first flew in 1976 and was combat ready by 1980, making it currently a 40-year-old design. It has been purchased by many countries, including Israel, Egypt, Turkey, and Denmark. An interesting design characteristic is the underside mounted air intakes, and these remain in service with the USAF now. We spin around looking at the B-2 again, which for me really was one of the highlights of the museum, seeing such a secret and current aircraft up close. We'll keep spinning around and first briefly look at the Northrop AT-38B Talon supersonic trainer jet. Previously, pilots would have gone directly from the basic T-38 into the operational fighter jet and then learn how to use the weapons then. But these AT-38B models were the trainers, but with gun sights, guns, rockets and bombs added, so the pilots could learn these skills while still flying the much cheaper trainers. In the background, this large imposing black jet is the Boeing B-1B Lancer. Originally designed to combine the speed of the B-58 and the bomb load of the B-52, this variable sweep heavy supersonic bomber was introduced in 1986 and remains in service to this day. There is a cockpit mock-up on display here that we can sneak into and have a look. For some context, the B-1A program, which was the base for this aircraft, was cancelled due to cost overruns, but due to the delays with the B-2 program, it was restarted and the design was upgraded, thus resulting in this new B-1B designation that we see here. It's powered by 4 General Electric F101 turbofans, producing over 30,000 pounds of thrust each, with an afterburner. Above here, you can see the moving mechanism with the wing, which will move forward for low speed lift during landing, takeoff and high altitude cruising up to 60,000 feet, and sweep back into this position that you see now for high speed flight. It uses a forward-looking and terrain-following radar, similar to what I described with the F-111, and has extremely accurate onboard navigation systems, enabling it to operate without ground-based navigation aids. It had 3 weapons bays and can carry a whole range of conventional and nuclear bombs and missiles. And it also has 6 external hardpoints that could carry up to 50,000 pounds, in addition to the 75,000 pounds internally. These were first used in Operation Desert Fox in 1998 and employed over Kosovo and Afghanistan. From 2002, the USAF started reducing the number of these, with a planned retirement in the middle of the 2030s. Operation Eagle Claw, the failed rescue mission of the Iran hostage crisis, highlighted that there were special operations that weren't suited to either fixed-wing aircraft or a helicopter. Therefore, the Department of Defense asked for an aircraft with long-range and high-speed capabilities in addition to vertical takeoff and landing. And in 1989, the Bell Boeing V-22 Osprey first took to the skies. Since then, over 400 have been built and they remain in service today. It features 2 turbofan engines and 3 bladed proprops mounted on the wingtips. During takeoff and landing, these are angled upwards as you see them now, but in flight they can be angled forwards, and it appears like a traditional plane, albeit with small wings. This CV-22B variant is for Special Ops Command and conducts long-range missions that has additional modifications including extra fuel tanks, terrain-following radar, and electronic counter-measuring equipment. It has a rearward opening ramp and can carry up to 32 troops or 10,000 pounds of cargo. It has a single 50 cal machine gun on the ramp and a crew of 4 with 2 pilots and 2 flight engineers. Next up, we have a 30mm GAU-8 Avenger rotary autocannon, and attached to that is a plane called the Fairchild Republic A-10 Thunderbolt II. This is a close air support aircraft designed to fly low and slow over the enemy and directly attack them, which is why the pilot sits in a bulletproof titanium tub and the engines are up above the fuselage to help protect them from small arms fire. In fact, there is 1,200 pounds of titanium armor throughout the aircraft, protecting important systems and the pilot. It was designed around this massive gun, and there has been one positioned next to the A-10's nose just to show how large it actually is. It can hit all types of ground targets with bullets, bombs or missiles, although it was especially designed to destroy tanks and other armoured vehicles. It was designed to have a long range, therefore a long loiter time, so it can sit and wait to be called by ground troops who need urgent assistance. With the powerful engines and straight wings, it is able to land and take off easily on short runways close to the front line. As we move towards the back, you'll notice that the tail has been split with 2 fins moved laterally like the Consolidated Liberator, and there's multiple reasons for this. It allows for the engines to be close to the centerline, so there's less of a problem if one fails, and it allows them to be up above the fuselage and away from the enemy's small arms fire. Having 2 fins also allows redundancy if one is destroyed, as some level of control will remain. By the way, that autocannon can fire 3,900 bullets per minute, so it would empty the entire store in just 18 seconds. This rather massive chopper is a Sikorsky MH-53M, which was involved with long-range special ops and actually replaced by the Osprey that we just looked at. This first flew in 1967 and was retired in 2008. Next up is the Lockheed AC-130A Spectre, which was a gunship version of the C-130 Hercules transport plane. It first flew in 1954 and remains in production and active with many nations around the world. It's an extremely durable design powered by 4 turboprop engines, which are frugal and easy to maintain, and used in a whole range of roles, including troop, medevac, and cargo transport, search and rescue, aerial firefighting, and in this case, a gunship, as you'll see when we get on the other side. These were designed to operate out of poorly maintained runways and deliver 92 combat troops, or up to 45,000 pounds of cargo. This was used primarily for night attacks against ground targets. In fact, this black device next to it is a General Electric AN/ASQ-145 low-level TV sensor system that was located right next to the guns and could amplify light 60,000 times so the crew could see their targets. The crews would use a laser, which was invisible to the naked eye but would show up clearly on the system to help them aim. There are multiple cannons, although the most impressive weapon was a 105mm cannon from an Army Field Artillery M1A1 howitzer, and it would be fired from the left or port side of the aircraft. There's a shell just behind it, and it really is massive when you consider that it's being shot from a plane. Apparently the whole plane would move 6 feet in the opposite direction whenever it fired. Just imagine how much it would all have weighed, and you can understand why they based this on such a sturdy transporter. Next we have the Panavia Tornado GR1, which was a twin-engine variable sweep multi-role supersonic aircraft developed by the British, Germans and Italians. This aircraft came about because the Brits needed a replacement for the Avro Vulcan and Buccaneer strike aircraft, and the TSR-2 and F-111K programs were cancelled. The Tornado was designed for low altitude and high speed penetration missions, and that was exactly what it did in the Gulf War. Right at the beginning, the RAF flew over 1,500 sorties to take out Iraqi runways and their radar and missile systems. And on the topic of sneaking into enemy airspace, next is the Lockheed F-117A Nighthawk attack aircraft. This was the first properly stealth aircraft using the unique faceted angular design, radar absorbent material and other design features like the V-tail and the engine inlets and exhausts were all released higher and above the view from the ground below. I talk about it in a lot more detail in my tour video around it on my channel. Of interest, it was a top secret program. In fact, one crashed in 1968 during development and started a bushfire, but the military swamped the area and even kept firefighters away. They quickly removed the F-117 debris and replaced it with a crashed F-101 Voodoo, which was stored at Area 51, ready to be used as a decoy. Now this had no defensive equipment itself, therefore it fully relied on the fact that it could hide from radars. It didn't even have a radar itself because the radiation emitted from that could be picked up by the enemy. It had 2 internal weapons bays and could carry guided bombs or a B-61 nuclear bomb. It was officially retired in 2008, although now it's used to train American pilots to fly against stealth fighters. And moving into the current era, here is a McDonnell Douglas F-15A Eagle. This is a twin-engine all-weather air superiority fighter first flown in 1972. Advanced electronic and stealthy technology were still a decade away, therefore the design philosophy with this was still lots of power. In fact, it was the first American fighter with an engine thrust ratio higher than its total weight, allowing it to accelerate while in a vertical climb. This has an M61 Vulcan cannon located internally, as they learned their lesson from the F4 Phantom II, which didn't originally come with one, because missiles were meant to be the future. As so happens, a gun was still needed, so the Phantom II eventually did get one. The F-15 has never been shot down by an adversary, while it has taken down 104 enemy aircraft itself, with half of those by the Israeli Air Force. In the late 1980s, the F-15 was used to test anti-satellite missiles, and actually did destroy a retired US satellite in a 345-mile orbit, just to prove to the Soviets that it was possible. It's also the only aircraft to achieve an air-to-air kill with a bomb when it destroyed an Iraqi Mi-24 helicopter with a GBU-10 laser-guided bomb. And yes, I did clarify that it was flying and not sitting on the ground. This was meant to have been retired and replaced by the F-22 in 2010, although they still remain in service because they're just so reliable, albeit with major upgrades. And speaking about the high kill rate, here's one of the victims, the Mig-29 Fulcrum. This was a Soviet response to the F-15 and 16 and designed as both an air superiority fighter as well as having ground attack capability. Introduced in 1983, it did lack the technology of those other jets. although fly-by-wire flight control system and composites were eventually added with subsequent upgrades, and it remains in production with over 1,600 built, flying for over 30 nations. You'll notice that on the nose landing gear there is a stone catcher to stop debris getting thrown up and sucked into the engine, as this is expected to operate from rundown Russian runways. With later technological advances, this has become a formidable adversary, at least in theory. It's powered by two ISO 12 RD33 turbofan engines producing over 18,300 pounds of thrust each with an afterburner, and has a top speed of around Mach 2.3. Now if we take a step back in time, we have the McDonnell Douglas RF-4C Phantom II, and looking at the nose, both angled forwards and to the sides, are a whole array of cameras. In the early 1960s, it became evident that more tactical reconnaissance aircraft were needed to support the RF-101s that we saw earlier, so they decided to modify the F4 Phantom IIs. They built just under 500 of these, and they could fly quick and low, snap photos of the damage, and then sneak away, as opposed to the other slower recon aircraft that were increasingly at risk from SAMs. These didn't carry any offensive armament, although some were fitted with 4 AIM-9 Sidewinder missiles towards the end of their service, in addition to the extra fuel tanks, recon, and ECM equipment pods. Jumping across, we had the Soviet Mig-29MS. This first flew in 1967 as a replacement for the MiG-21. As the air intakes have moved to the sides, this freed up the whole nose for the Sapphire 23P radar. This was the first Soviet radar capable of identifying objects below the aircraft, as up until then, if the antenna was angled towards the ground, it would be overwhelmed from the ground reflections, therefore see nothing. Up until now, the American aircraft could simply sneak underneath Soviet aircraft by flying low. This advanced radar and new missile technology also made this one of the first aircraft armed with beyond visual range missiles. Powered by a single afterburning turbojet, it also came with variable sweep wings and, as you can see, stone deflectors over the wheels so that it could operate from short and rough runways. This actual aircraft was an MS model, which was for exports and came with a less sophisticated radar. It was also used in a top-secret program to provide American fighter pilots with realistic combat training against Soviet technology. This here is an F4G Wild Weasel. As you may recall, the F-105 Wild Weasel earlier, which would fly into enemy areas before the bomber fleet and draw out and destroy SAM sites, these were essentially F-4Es, although the internal cannon was removed and replaced by electronic warfare equipment. You may recall that the original F4 Phantom II did not come with any internal weapons, although that was rectified with the E model. These were faster and better armed than the F-105, and the primary weapons was an AGM-88 HARM anti-radiation missile. These have since been retired, and their role was taken over by the F-16. Moving back in history, and we have the Convair F-106 Delta Dart. This was an all-weather interceptor and significantly upgraded version of the F-102 that I'll show you soon. These were designed to patrol the north and be ready for a fleet of Soviet bombers. It was designed to use the AIM-4 Falcon missiles or Genie nuclear-armed rockets with no provision for guns or bombs. The idea was that if there was a large pack of Soviet bombers flying over Canada, then they would detonate this nuclear missile in the middle of them. This actual aircraft is famous for an incident in 1970 when the pilot had to eject due to an uncontrollable spin, and the aircraft, without a pilot, leveled itself and belly landed in a field of snow. It was repaired and then returned to service. This large turboprop cargo aircraft is a Douglas C-133A Cargo Master and first flew in 1956. That large dark bulge on the nose was the radar installation, as you have to remember that this technology was only just starting to be installed into aircraft, therefore space often wasn't created during the design process, so they had to take it on afterwards. The C-133 was rushed into the air. In fact, there was never a prototype, and they were delivered to the USAF immediately. This was different from the C-124 Globemaster II that you saw earlier, both in the size and the number of different design features. It had a high mounted wing which raises the props further away from the ground, thus allowing the whole fuselage to be lower while allowing easy access for the cargo. The main landing gear was put in external blister fairings on the sides of the fuselage, allowing the cargo hold to be uninterrupted. The fairings could also be used for other things, as you see in my Antonov AN-22 video, where multiple APUs and fuel tanks were installed in there too. These also have side-mounted and rear doors allowing for quick access to cargo, and the compartment bay was pressurized, heated and ventilated as well. While it wasn't originally planned, these ended up being used to transport Atlas and Titan ICBMs, which were considerably faster than driving them across the country on the back of a truck. This aircraft on display established a world record for a prop-driven aircraft when it carried 117,900 pounds up to 10,000 feet on December 16, 1958. These aircraft were replaced by faster jet-powered C-5 Galaxy and C-141 that you'll see shortly. This here is another F-100 Super Sabre, which you may recall you saw earlier, although this one is the single-seat D model. You'll notice a large nose boom, which has been folded up to avoid hitting pedestrians. Some older aircraft had these because the idea was that as you reached the sound barrier, the air in front of the aircraft would be compressed, and this would affect the accuracy of any pitot tubes. Therefore, they stuck them well forward of the fuselage, although this didn't end up being a huge problem, and the newer and extremely fast jets have standard pitot tubes. We'll have a brief look at this incredible SR-71 Blackbird, although we'll come back to that later, and its very rare YF-12 brother. Next is the Mcdonnell F-101B Voodoo. This was originally designed as a long-range bomber escort, but when the high-speed and high-altitude bombers such as the B-52 entered service, the Strategic Air Command no longer needed bomber escorts, so the role was changed to tactical and air defense. These were fitted with unique rotary armament doors underneath that could carry AIM-4 Falcon missiles and even Air-2 Genie nuclear rockets. This was extremely powerful. In fact, it was the only one of the Century jets that came with two engines, which in this case were two Pratt & Whitney J57s producing 16,900 pounds of thrust each. And here's the tail end of the F-106 that we saw earlier, and the exhaust of its single engine, and overall its much narrower fuselage. By the way, the Canadian government considered buying these F-106s to use as their own all-weather interceptors, although they ended up getting F-101s, which they renamed their CF-101, although they were still manufactured in Missouri in the USA. This large dark thing, painted with a dark underside because it flew so high that it camouflaged against the black void of space rather than the blue sky, is the Martin RB-57D Strategic Reconnaissance Aircraft. Remember, the B-57 is an American-built version of the English Electric Canberra, and this is a significantly upgraded version of that with larger wings and more powerful engines. This entered service the same year as the U-2 and could fly a larger payload and faster, although not quite as high as the U-2. On the 11th of December 1956, 3 RB-57Ds overflew Vladivostok in broad daylight. The Soviets protested, leading President Eisenhower to end military overflights of the USSR, although later U-2 missions were flown, but that was by the CIA, which technically isn't the military. There were a number of wing failures on these, leading to their removal from service, although some continued in a research role. Next is the Lockheed F-104C Starfighter. What stands out is how much smaller this is than many other fighters from that era. Kelly Johnson interviewed a number of Korean War pilots, and he decided to reject the trend of making fighter jets bigger and more complicated and went back to basics with this very small and light single-engine jet. And it worked to an extent, as it was the first production aircraft to achieve Mach 2 and an altitude of 100,000 feet after taking off on its own power. We'll come back to it and now look at the Convair F-102A Delta Dagger. This was the first USAF jet with a Delta wing and the first supersonic all-weather interceptor aircraft. It was operated by the Air Defense Command, and its job was to sit and wait for an incoming Soviet bomber, quickly launch and then take them down. In Vietnam, it also had a limited ground attack role and a bomber escort. This was fitted with weapon systems that would detect the enemy aircraft, then fly the jet to the correct location and launch the missiles automatically, thus freeing the pilot to do other jobs. This allowed them to build it around a single crew member, although there was a trainer version with 2 seats that were in a unique side-by-side layout. It had an internal weapons bay with room for AIM-4 Falcon air-to-air missiles and AIM-26 Falcons that could carry nuclear warheads to take out a larger Soviet group of bombers. Inside the missile bay doors, and I'll show you this in a separate video, they could store up to 24 unguided rockets. By the way, this actual aircraft here is the one in this photo intercepting a Soviet Bear bomber. Work was advancing on replacing the J-57 engine, amongst other upgrades, with the F-102B model, although the upgrades eventually became so significant that it was redesignated the F-106 that I showed you earlier. Here we are back at the Starfighter. As you can see by looking at it, it's really quite small, and it was marketed by Lockheed as a missile with a man in it. It had a really unique wing that was quite small, and as you can see, also extremely thin. In fact, they would put a protective barrier on the edge because it was so sharp that it could cut an unsuspecting maintenance engineer. To help improve lift from those little wings, which otherwise provided brilliant high-speed performance, they had a boundary layer control system where the air was bled from the engine and blown over the wing's trailing edge to improve low-speed lift. This did help, but it also meant that you had to keep the throttle up. In fact, the engine had to be running at over 80% speed to maintain the system. Having such a thin wing meant that no fuel could be stored internally, hence why those wingtip mounted fuel tanks were there, and they could have been removed and replaced with missiles as well. And next up, another Lockheed, the SR-71 Blackbird, which is always a pleasure to see in the titanium. I talk about this in far more detail in another video, so I'll just mention a few interesting points. You'll notice the silver coloured wheels, and that is because so much heat would be generated flying at Mach 3 that standard rubber wheels would melt. Therefore, aluminium was put inside the rubber to ensure they'd maintain their shape. You'll see shortly that the nose wheel is black, and that's because cold air from the cockpit was pumped into the forward landing gear wheel well, and that kept the temperature down. These chines running along the sides always gave it a menacing look, but also provided lift and reduced its radar cross-section. In fact, they used radar absorbent materials on the skin, therefore this was also somewhat stealthy. Under the nose here, you have the electronic countermeasure equipment that would detect an enemy missile and then direct energy at it to confuse it. What's interesting is that they only had these on the front of the aircraft because they didn't care about missiles behind it, as it could simply fly faster than them and escape. Next we have the Boeing RB-47H, which was an electronic reconnaissance version of the B-47 Stratojet strategic bomber. The B-47 incorporated the swept wing, using 6 turbojets positioned in under-wing pods, fuselage-mounted landing gear because the wings were kept thin and weren't strong enough, and it introduced automatic systems allowing for it to fly with a crew of just 3. The RB-47 removed the offensive equipment and instead was covered in sensors. During the Cold War, the US needed to gather information about Soviet air defenses, such as their locations, range and coverage, so these jets would fly thousands of what they called ferret missions in radio silence at night along the border picking up radar information. Sitting under the bomb bay was an inert Mark 41 thermonuclear bomb first produced in 1960. It was carried by B-47, 52 and planned for the B-70s. Released from high altitude and used parachutes to delay the detonation to allow the aircraft to escape at full throttle. Turning around, and we have the Northrop F-89J Scorpion, named the Scorpion because the horizontal tail was moved up the vertical tail to keep it away from the jet exhaust. This was an all-weather fighter and the first to be designed from the start to be an interceptor. It was originally designed with a swept wing, which engineers now knew would support the high speeds, but the poor low speed characteristics resulted in it being replaced by a thin straight wing, as you can see here, with fuel tip tanks. Just quickly, this is the ejection pod from an F-111 that we saw earlier. Because it could fly so fast, a simple ejection seat wouldn't protect the pilots from the supersonic wind, so instead they designed a whole pod that could be ejected, and it came with its own flotation equipment if it landed in water. Of interest, the F-89 was the first fighter armed with and test-fired nuclear air-to-air missiles in the form of the unguided Genie rocket I mentioned earlier. It had 2 crew members, with the pilot in front, and behind them was the radar weapons officer helping find the Soviet bombers and shooting them down. In addition to 2 of the Air-2A Genie air-to-air rockets with nuclear warheads, it also carried 4 AIM-4 Falcon missiles. Next is the Convair B-36J Peacemaker, which is absolutely massive, but wait until I show you the original landing gear. There were fears that the UK would fall to the Nazis, so the US had to design a bomber with a much larger range that could fly across the Atlantic, drop bombs, and then return to the North American continent. This was all instead of basing their bombers on UK soil. This strategic bomber first flew in 1946, and while World War II had ended, the threat from the Soviets remained. Originally designed to carry conventional bombs, it was then modified to carry the gigantic Mark 17, which was the first American thermonuclear weapon, or H-bomb. It weighed an incredible 41,400 pounds, and when dropped, apparently the aircraft would rise several hundred feet due to the reduced weight. So that it could fly such a huge distance, it had massive wings, and to keep them as slippery as possible, the 6 props were positioned behind them. It was also fitted with 4 turbojet engines further out, and interestingly, they burned the same fuel as the props. Here's the production main landing gear, and behind it was the original proposed single wheel from the XB-36 prototype. The problem was that these single wheels would focus all of the weight onto a smaller surface area, resulting in the runways being damaged, as well as taking up extra room in the fuselage, which could otherwise be used for fuel or bombs. Walking underneath, we can see part of the bomb bay, and it really is massive in here. In fact, there were plans to fly a jet fighter out of here to act as a short-range bomber escorter, and I'll show you one of those, an XF-85 Goblin, later in the video. Check out my B-17 and B-29 tours, where I also go inside their relatively tiny bomb bays. While it obviously never dropped a bomb in anger, it was used for research, including one model being fitted with a nuclear reactor to research nuclear propulsion. While a later YB-60 model was put together with swept wings and 8 jet engines, it became quickly outdated with the arrival of the much more capable B-52. Moving a few years into the future and flying from 1956, we have the Convair B-58 Hustler, which was the first operational nuclear bomber capable of Mach 2 flight. It's still a big plane, but smaller than many other bombers, and used a delta wing design with 4 jet engines in pods underneath the wings. It had a remarkably small fuselage, which allowed for high speeds, but didn't leave much room for fuel or bombs. In fact, the joke was that it was a great aircraft if they needed to nuke Canada. That large pod underneath that looks like an auxiliary fuel tank was actually a permanent attachment with fuel that could also include room for a nuclear bomb, which is the silver object sitting on the aircraft's starboard side. Ejecting from such high speeds was a problem, so this escape capsule had airtight clamshell doors that could close, and the pilot could keep flying the plane from inside it. Then if all hope was lost, he could eject safely inside the capsule. On the other side of the aircraft, we get a good view of that ventral pod, and we see the 3 crew positions with the pilot, the radar navigator bombardier, and the defense systems operator at the back. This was designed to fly at high altitudes, but with the introduction of Soviet high-altitude SAMs, this then flew low-level penetration flights, where it wasn't a great deal better than the B-52, which was much cheaper and had a larger payload. There were also a lot of accidental losses, and this was eventually replaced by the B-52 and the F-111. This is a Northrop SM-62 Snark, which was an intercontinental cruise missile with a nuclear warhead. When compared with a bomber, this was cheaper to maintain, it didn't risk the crew, and had no need for refueling aircraft, but navigation was initially a problem, so this came with an advanced inertial navigation system corrected by star tracking. They were only in service from 1960 to 61 as ICBMs superseded them, and I'll show you those later. Here's an F-86 with the exterior panels removed, giving you a great view of what's underneath. By the way, let me know if you enjoy these long guided tour videos through aircraft museums by commenting below. They do take a long time to edit, so I'd appreciate the feedback. The large aircraft in the background is a Boeing KC-97L Stratofreighter, which was the tanker version of the B-29 Superfortress. As you can see, in addition to the 4 Pratt & Whitney R-4360s, there were also 2 J-47 turbojets stuck on the end of the wings to provide additional thrust. This silver missile is a Martin CGM-13B Mace cruise missile launched from the ground, and that white rocket at the tail, before then flying onwards with an internal Ellison J-33 turbojet engine. It could carry either conventional or a nuclear warhead and had onboard navigation systems, while its predecessor, this green TM-61A Matador, required ongoing directing from the ground. This was the first American-designed pilotless bomb, and the first launch took place in 1949. Looking back at the KC-97, and it's interesting to note how they got the B-29 and added a second lobe on top of the fuselage and wings, and it's really evident from this angle. While this did have a large payload, the reality was that jet fighters were now becoming the norm, and they were finding that this just couldn't keep up. The jets would need to slow to almost their stalling speed, while this would be flying at full throttle just to keep up with it. This went on to be replaced by the jet-powered KC-135, which you'll see later in the video, which was then modified into the Boeing 707, which revolutionized civilian aviation. This jet in front of you is a Republic F-84F Thunderstreak. You may recall seeing the straight-wing F-84 earlier in the video, but this was a later model integrating the more advanced swept-wing design. This was a fighter bomber with 6 50 cal machine guns and 24 5-inch rockets. Sitting just forward of the port wing here is a Mark 7 nuclear bomb, which was the first American nuclear weapon small enough to be carried by a fighter. There was also a reconnaissance version of this, the RF-84F, which had cameras installed in the nose, and the air intakes were moved to the wing roots. By the way, if you enjoy these types of videos, then please subscribe and check out my channel. There are many more similar videos filmed at aviation museums across the USA, Europe and Australia. And here we are, swooping past the tanker again, and we'll go and have a look at its brother, the WB-50D, also based on the B-29. With more powerful engines, a taller tail fin, a stronger structure and other modifications, this upgrade to the B-29 was redesignated the B-50 and was the last prop-driven bomber delivered to the USAF. The Strategic Air Command replaced these with jet-powered B-47s that you saw earlier, so many of these were modified into other roles including weather reconnaissance, and that's what this aircraft was used for. The defensive armament were removed and replaced by atmospheric samplers, Doppler radars and bomb bay fuel tanks for extra range. They also flew a few sniffing missions to sample the air for radioactive particles, suggesting that the Soviets had detonated nuclear bombs. I have a separate video where I crawl right through a B-29 in Arizona. That tour includes the cockpit, the bomb bay, and right back to the tail gunner's position. I'll link to that video in the description below. Next up is a Lockheed F-104C Starfighter with a fascinating nose that you'll see shortly. As you may recall, this was the first generation jet-powered all-weather and night interceptor and based on the T-33, which itself was based on the F-80, the first mass-produced USAF jet fighter. The C model was a major upgrade, including more powerful engines, single-point refueling, a new wing and swept-back horizontal stabilizer, upgraded navigation and fire control systems, and mid-wing rocket pods. There were also 24 rockets carried in a ring around the radome protected by retractable doors. This was not fitted with any guns itself. Here's 2 turbojet engines fitted to the B-36 from earlier, and remember that they were unique in that they ran on the same fuel as the piston engines to reduce weight and complexity. Modern jets all had a separate type of fuel. These jet engines would be turned off during the cruise, so mostly used just for takeoff and the climb. Here's a North American F-86 Sabre, and we've seen this before, but this is a D model, which was actually originally designated the F-95 due to the fact that it only shared 25% parts with the original F-86A. While the original was a day fighter, this had an AN APG-36 weather radar fitted in the modified and larger nose cone, thus allowing it to operate in an all-weather fighter role. It also had a wider fuselage and a longer airframe than the original. They also removed the guns, and it only came with unguided Mighty Mouse air-to-air rockets, released from the underside tray, which you can see deployed here. Next is the only Canadian designed and built fighter to go into large-scale production, the Avro CF-100 Canuck. If the Soviets were going to hit the USA, they'd be flying over Canada, so protecting that airspace was very important. These 2-seat all-weather interceptors were powered by Canadian-developed Orendo turbojets and were armed with 8 50 cal machine guns and 58 2.75-inch rockets. Above is a T-33 trainer that I've mentioned a few times, but we can't really see it that well, so we'll move on. Here is another twin Mustang that we saw earlier, and that completes this section of the museum. The next massive hangar includes the Presidential Gallery, the Global Reach Gallery, Space and Research, and the Developmental Gallery. This large white rocket is a Lockheed Martin Titan IV-B, which is the largest and most powerful USAF single-use rocket. It was a space launch vehicle used to put satellites into orbit. In fact, it could lift payloads up to 23.9 tons. Next, we have this Mercury spacecraft, which was used as the first vehicle to carry Americans into space. The goal of this program was to confirm if a human could survive in space and bring them home safely back to Earth. 6 flights from 1961 confirmed that they could. This actual vehicle here was flight rated but never flew and used to provide spare parts for the final Mercury mission. As you can see looking inside, there was room for 1 crew member. Located at the smaller end was a parachute which would have been inside this empty section here, and during its re-entry through the Earth's atmosphere, it could fly with the other end down with the thickest heat shield that had been partially removed so that we can see what's underneath. It's pretty incredible to think that a man will be able to sit alone in this little shoebox so far from the Earth's surface. These could be launched by sticking them on top of modified Redstone and Atlas ballistic missiles. Next is the Mcdonnell Gemini B, which was a modified version of the capsule used during the Gemini program between 1965 and 66. This was a top secret program where astronauts were to operate cameras and take photos of their adversaries. The biggest difference is that this had a circular hatch through the heat shield on the underside of the vehicle. This would lead to a tunnel connecting to a 19-foot long manned orbiting laboratory module, where the crew would live and control the cameras. These missions were to last up to 30 days, and the Gemini B vehicle was only used to transport between the Earth and the module. This program was cancelled in 1963 before any missions, although 17 military pilots did begin their training. And spinning around, we have the North American Rockwell Apollo 15 command module, and you can see the charred underside heat shield from the re-entry. This was used to fly to the moon in 1971 and take part in the 4th successful moon landing, which was the first to use a lunar rover vehicle. The crew spent 4 days travelling between the Earth and the moon and 67 hours exploring and setting up experiments on the moon before returning to Earth and splashing down in the Pacific Ocean near Hawaii. This next object is a Northrop Grumman Defense Support Program satellite. These had infrared sensors that could identify Soviet or Chinese nuclear ballistic missiles. Since the end of the Cold War, they've been used elsewhere, such as identifying Iraqi Scud missile launches during Operation Desert Storm. We'll look at this blue aircraft hiding back here later, but let's spin around and have a look at some of these other aircraft. This handsome devil on the left is a Martin X-24A lifting body. This was used by the USAF and NASA to study the flight characteristics of lifting bodies, which is a fixed-wing vehicle such as a space shuttle orbiter, where the lift is produced by the body rather than a traditional wing. This was dropped by a B-52, followed by a rocket burn to gain altitude, which on the final flight was 71,000 feet, and then it would glide back to Earth, proving the concept of the orbiter that would follow. Next to it is the X-24B, which was a part of the same research. In fact, other than the extended nose, you'll notice that the rest of it looks similar to the A model. This made 12 gliding flights and 24 powered flights with gliding landings, including 2 very precise landings on a concrete runway at the Edwards Air Force Base, other than the usual dry lake bed, like all the previous landings. It was boosted up to altitude and speed by a Reaction Motors XLR-11 rocket shed with the Bell X-1, and it also had 2 Bell landing rockets as well. Under the incredible XB-70, we have the Bell X-1B, which was not the orange supersonic record breaker, as that will be in my Smithsonian video. This was an aircraft powered by rocket engines and used to research aerodynamic heating, and used the reaction rockets for directional control. Much of what has been learned was then explored further with the X-15, which you'll see in a minute. This would be launched from a mother plane, fire the alcohol-water mixture of fuel with liquid oxygen, and then it would glide down to Earth. And on the topic of aerodynamic heating, the XB-70's tyres had aluminium in the rubber to help manage the extreme heat, as we saw with the SR-71. Between the wheels was a much smaller one, and this was a part of the very primitive anti-locking braking system that it had. The Russians are bragging about hypersonic missiles, yet the Americans have been travelling that fast for decades and had humans on board, including Neil Armstrong. Now here is the incredible North American X-15A-2 hypersonic researched aircraft. These fluoro-coloured tanks on the sides of the fuselage were additional fuel tanks, providing for a longer burn. There's no traditional pitot tube on this, as they would melt, so the nose had holes that very cleverly calculated airspeed, and you'll see warnings for the blast from the nose, and that's because this would fly up so high that the air was extremely thin, so rockets were required to maintain control of the aircraft. The single engine itself is actually pretty small, so the rest of it really was just a massive fuel tank. It's an XLR-99 rocket engine and produces 57,000 pounds of thrust, propelling this actual aircraft to a record-breaking Mach 6.7 in 1967. There are only 2 of these intact anywhere in the world, after another one was destroyed, so it's really special seeing this up close. I have another video where I crawl around this aircraft in more detail, and I'll link to that below. The engine would burn 15,000 pounds of propellant in just 80 seconds, although their side tanks added another 60 seconds of fun. To save weight, it didn't have a main landing gear and simply landed on sleds, which was okay as it landed on a dry lake bed, although it did have a nose wheel. Next is the Douglas X-3 Stiletto, and apologies that the lighting isn't great as this was sitting underneath the XB-70. This is the only one ever built, so it was a privilege to see it in the metal. This twin turbojet was designed to test sustained Mach 2 flight and also tested the use of very short wings and titanium airframe construction. It had engine problems, but was still a useful aircraft, and lessons learned were integrated into the F-104, X-15 and SR-71. Looking up at the XB-70's wing, and you'll see this black joint in the wing, where the outer part would fold downwards and catch the shockwave that was generated by the splitter in front of the engines. It really was an incredible aircraft, and I go around that in more detail in a separate video. Now, sorry to keep plugging my own other videos, but if I talk so much about each aircraft in this video, then it would go for around 6 hours, so I'll link to all these other videos below. It was powered by an incredible GE YJ-93 after burning turbojet, producing 28,000 pounds of thrust each, pushing it to a top speed of Mach 3.1, which is an amazing number for an aircraft of this size. As many of you will know, only 2 were built, and the other one was destroyed in an accident, so this is the only one left. This white jet is a Convair XF-92A, which was the world's first jet aircraft with a radical delta wing. With the information obtained from this, Convair were able to make the first mass-produced delta wing fighter, the F-102, which I showed you earlier in this video. This is the only XF-92 built and was flown by the USAF and NACA, which was the predecessor to NASA. It was flown from 1948 until a nose gear collapsed during landing in 1953. The actual original 1945 F-92 was a swept-wing short-range supersonic interceptor, powered by several rocket engines and a ramjet. While that's incredible, it wasn't practical and the program was cancelled. Now, do you remember the massive B-36 I showed you earlier, which was designed to fly from North America, bomb Germany, and then back home on a single tank of fuel? Obviously, no fighter escorts had the same range, so they came up with the idea of storing small jet fighters inside the massive bomb bay, and that was this aircraft. This is a Mcdonnell XF-85 Goblin powered by a single Westinghouse turbojet and had 4 50 cal M3 Browning machine guns. In the end, the hooking process to get back on board the mothership was extremely dangerous and the program was cancelled. Next is the Fisher P-75A Eagle, and the only one on display anywhere in the world. During World War II, there was an urgent need for an interceptor with a very high rate of climb, so they needed to use the most powerful engine available, but otherwise try and use as many components from other aircraft to expedite the design process. Interestingly, they positioned the engine in the middle behind the cockpit and used contra-rotating props. The mission was eventually changed to a long-range escort role, and the P-51 Mustang could do that, so the program was cancelled. There's the engine and the drive shaft sitting here in front of the aircraft. Jumping back along the path is the Bell P-59B Aerocomet. This was the first American jet, but the performance was disappointing, so the USAF went with the F-80 that you saw earlier, thus making that the first mass-produced jet. Now, this was so secret that they would attach a fake propeller and cover the engine intakes and exhaust as to confuse any spies, as you can see with this photo. Here's a General Electric turbojet from the era, and it's interesting how much shorter these were than later turbojets. Up above, and it's too hard to get a close look, so we'll continue on shortly, is the Grumman X-29A, which is the world's first supersonic forward-swept wing jet. Back on the ground is the Republic XF-84H, famously called the Thunder Screech because the noise was known to make people physically ill. It was powered by a turboprop engine, with the idea being that it would provide the low fuel consumption, long range and low landing speed of a prop plane, and higher speeds of a jet. It used a modified F-84F airframe and a triangular shark fin just behind the pilot to reduce the effect of the torque from the props. It was one of the fastest single-engine prop planes, but never got close to supersonic speeds, so it was cancelled, much to the relief of the nauseated ground crews. The next aircraft is quite literally a flying saucer. The Avro Canada VZ-9AV Avrocar was the result of a program to develop a supersonic vertical takeoff and landing fighter bomber in the 1950s. It was powered by multiple jet engines that turned a central turbo rotor that would create a cushion of air. Then the air would be directed towards the rear, pushing the aircraft forwards. It didn't really work and the program was cancelled. Next is the Bell helicopter Texton XV-3 from 1951 and was a joint USAF and Army project, resulting in the first successful vertical or short takeoff and landing tilt rotor aircraft. It's powered by a single 9-cylinder radial piston engine linked to two 3-blade rotors on the wingtips that can tilt 90 degrees. As we saw with the Osprey I mentioned earlier, it had great potential but difficult to engineer, and only 2 were ever made. A somewhat alternative, although similar idea, was to create a jet that could land and take off vertically, but then fly horizontally. This here is the Ryan X-13 Vertijet, and it was powered by a single Rolls-Royce Avon turbojet, with a vectored exhaust controlling pitch and yaw, and small puffer jets on the outboard of the wingtip end plates controlling roll. It did successfully fly, but the funding dried up, and it then became a museum piece. Next up is the Northrop Tacit Blue, which was nicknamed the Alien School Bus, and you can kind of understand why. It was a technology demonstrator testing the rounded stealth design and a low probability of intercept radar. Prior to this, which first flew in 1982, stealth aircraft like the F-117 relied on their angular design to reduce their radar return, but this was testing the rounder shape that we saw on the B-2 Spirit. You may not realize that the F-117 didn't actually have a radar because the enemy would be able to identify that, so this had a unique radar design where the frequency can be constantly changed and the scan pattern is irregular, amongst other tricks. That radar then went into the B-2. This was never meant to go into production, well, not that we're aware of anyway, and it was designed to fly above the battlefield without being noticed and send live updates back to headquarters. It was declassified in 1996. Next is a Lockheed YF-12, and the only one in existence anywhere in the world. This was a proposed interceptor based on the A-12 and SR-71 reconnaissance aircraft. Instead of camera equipment, it was fitted with a Hughes fire control radar and AIM-47 Falcon air-to-air missiles, hence the slightly different looking front end. The chines are blunted because of the sensors, and the whole nose cone is rounded, as that shape would have worked better with the internal radar. It was revealed by President Johnson in 1964, which was possibly just to provide plausible deniability for the A-12 fleet operated by the CIA, which looked very similar. They weren't meant to be spying on the Soviets, so they could simply claim that any SR-71 spotted was actually an F-12 interceptor undergoing testing. Looking up at the XB-70 once again, and the rather large canards. Its delta wing was great for high speed, but the low speed lift generated was poor, therefore this canard helped with that and thus made landing and takeoff easier. As you can see, the rear half of the canard could fold down, operating like a trailing edge flap. You don't appreciate how large and tall this aircraft is until you're standing underneath it. Spinning around, and we have this central splitter and the 2 air intakes located on the side of that. Remember that this central splitter created a shockwave that moves it back along the side of the fuselage and is caught by the wingtips that fold downward in flight, which all contributes to the lift generated. It really is a novel design and looks brilliant. Next, we start at the tail of this Hawker Siddeley XV-6A Kestrel, which was a British prototype vertical short takeoff and landing or V-style aircraft. A modified version went on to be called the Harrier and was the world's first operational V-style fighter, entering service with the Royal Air Force in 1969. The US Marine Corps flew them for several decades as well. This large white vehicle is the one remaining North American X-10, which was an unmanned technology demonstrator built by North American. It was used to test the flight characteristics, navigation and control systems of the planned SM-64 Navajo, which was a nuclear-armed ramjet-powered Mach 3 cruise missile. But development of that was stopped after it became evident that ICBM technology would supersede it. The leftover X-10s were then used to support the XB-70 role and as targets for surface-to-air missiles under development. Jumping a little forward, we arrive back at the tail end of the tacit blue you saw earlier, and this small object is the XST Have Blue radar cross-section model. This was stuck on top of a pole and used to test the radar return, and from that they built the piloted Have Blue that flew, and that led to the F-117 that you saw earlier. Note that the shape is mostly the same, although the tail fin on this is angled inwards. Next is a really special bird, and it's the YF-23 Black Widow 2, which was Northrop's submission to the Advanced Tactical Fighter program in the late 1980s, but lost to the F-22 Raptor that you saw earlier. This integrates many stealthy features, including this tail end, where the exhaust was released well before the fuselage ends, and mixed with cold air to reduce its heat signature. It also had a unique looking V-tail, which would have a lower radar return than a traditional one. It also didn't have pitot tubes, as that would reflect radar waves, although this prototype did, just to test that the alternative system was working. There's always comments about political interference, although I suspect that this was just too abstract and the Air Force were worried about cost overruns. The YF-22 that this was competing with was much closer to production when the competition took place. There's only 2 of these anywhere in the world, and it's a real treat to see. This white blob is a Lockheed Martin X-24A, which was a technology demonstrator built by the Skunk Works and flew in 2001 but not declassified until 2018. It was used to test the tailless design and remote flight controls, and I'm just guessing here, I bet there's a bigger and still classified version of something like this flying at the moment. All speculation, of course. Next is the Boeing X-45 technology demonstrator, and this also tests the tailless stealthy design, but also flight automation. Onboard computers do all of the flying and minor decision making, while the human on the ground makes the big decisions. In fact, one person can operate 2 of these at the same time. This X-36 was a scale model possible fighter design without a tail, with canards and controlled remotely. The test program went very well, and then it was suddenly cancelled, well, publicly at least, so I do wonder if we might see aspects of this design again. This is a Kratos XQ-58A Valkyrie, which is a stealthy unmanned combat aero vehicle built in response to the growing cost of piloted aircraft. This would act as a loyal wingman and support a manned fighter and operate as part of a swarm of drones with or without direct pilot control. Next we have the Fairchild C-119J, which was a military transport aircraft and developed from the World War II era C-82, and first flew in 1947 with over 1,100 built. This was especially important in the Korean War and involved in an important airlift mission in 1950. These dropped portions of a bridge to US troops trapped by communist forces at the Kozan Reservoir. The ground troops were then able to rebuild a bridge, and thousands were able to escape. These also operated in Vietnam, where they were converted into gunships, much like the later AC-130 Hercules. This actual aircraft was important because in 1960 it caught the Discoverer 14 satellite with a mechanism that was released from the cargo hold. Satellite catching became important in a regular US Air Force operation to catch reconnaissance films from spy satellites, like the one you saw earlier. Next is the LTV XC-142A, which was another vertical or short takeoff and landing aircraft prototype, of which 5 were built, and this is the only one remaining. This first flew in 1964, and while it was successful, sponsors lost interest and the program was cancelled. This works a little different to some other V-style aircraft, because instead of the engines angling upwards and the wing remaining static, with this the whole wing and engine mechanism will change its angle upwards for the landing and takeoff. Here's a photo of it flying to show you what I mean. The wings could actually be rotated to 100 degrees, so past vertical, therefore it could fly backwards. You'll notice that there is another propeller located right at the tail end, and that was for the pitch control. All 5 props were driven by 4 turboshaft engines that were cross-linked to a common drive shaft, which removed the problems of engine-out asymmetric thrust. This troop carrier is a Fairchild C-82A Pocket, which was the predecessor to the satellite catcher that you saw just a few minutes ago. This was a large capacity cargo aircraft that could be easily loaded from ground level, and the prototype first flew in 1944. This had a number of design features that became the norm, including a tricycle landing gear with a reasonably short nose wheel to keep the whole aircraft as low as possible, high wings that also allowed for a low fuselage, and the props are still kept high up from the ground, and it had a high tail boom that didn't impede access. The large rear doors were also much easier to use than the smaller side-mounted doors of many other earlier cargo planes. In the shadows here is a Lockheed P-80R, and this was the only one ever built. It was a modified P or F-80 that was the first jet fighter used by the USAF, and you saw one earlier in the video. This one was designed to beat the world speed record that was held by the British Gloucester Meteor. It had a smaller canopy, redesigned air intakes, a shorter wing, they replaced the guns with fuel tanks, and the surfaces were made as smooth as possible. In 1947, it did set a record of 623 miles per hour. Here we are walking underneath the C-130, and we'll walk over to the Presidential Aircraft Gallery. In front of you is SAM 26000, which was the Boeing VC-137C, a VIP version of the Boeing 707-300. This was involved in many momentous events, including flying JFK to Berlin for his famous speech. It also flew JFK to Dallas and flew his body back to Washington after the assassination. Lyndon Johnson was also sworn in on board this very aircraft, and I'll take you inside the cabin in another video, where I'll also show you where the seats were removed to fit the casket on board. This tri-tailed airliner is Columbine 3, a Lockheed VC-121E, based on the Super constellation that served as Eisenhower's personal plane from 1954 to 1961. This followed on from Columbine 2, also a Connie, which was the first aircraft to be called Air Force One after a confusing mix-up with flight numbers that could have almost resulted in a collision. Prior to then, they simply used military flight designations. These Connies introduced a whole range of comforts, including cabin pressurization, that allowed it to fly higher and over rough weather. Here's 2 small aircraft that also carry the president, but the smaller size allowed them to travel more lightly and also causing as little fuss as possible. This VC-140B here was sometimes jokingly referred to as Air Force One Half. Next to that is its replacement, the Gulfstream Aerospace C-20B, which came with an upgraded security and communication system to allow pilots to communicate privately with whoever they needed to. These smaller aircraft were obviously ideal for visiting smaller airfields where the 707 or 747 base jets wouldn't fit. Next is Independence, a Douglas VC-118 based on the DC-3. It was used by President Truman and was the second aircraft used specifically to transport the president. The name comes from his hometown of Independence, a city in Missouri. In addition to the VIP furbishings, it carried additional fuel tanks so that it could fly anywhere within the USA non-stop. This chrome aircraft here is the first ever aircraft built from the start to carry the president, and it's a Douglas VC-54C. As I said earlier, they actually considered a transport version of the B-24 bomber, although the Secret Service expressed concerns about its safety, so they decided to base it off the trusty DC-4. It had a battery-powered elevator installed in the rear of it to allow President Roosevelt to board easily in his wheelchair, and it carried him to the Yalta Conference in 1945. The following president, Harry Truman, signed the National Security Act of 1947 on board this, and that established the US Air Force as an independent service. This was nicknamed the Sacred Cow because there was such a high level of security around it. Moving on, and we have the Lockheed C-141 Starlifter, which was the replacement for the propeller-driven C-124 Globemaster and the C-133, the both of which you saw earlier. It has a large rear opening doors, allowing cargo to be driven on board, which is much easier than side-mounted doors. It had a similar shape, with the high-mounted wings and the landing gear in fairings on the side of the fuselage, allowing the cargo bay to fill the entire width. While it's clearly very long, it's only 10 feet wide, limiting what could be driven on. In contrast, its replacement, C-17 Globemaster III, had an 18 feet wide cargo compartment, and you'll see that aircraft later. 10 feet does seem narrow by modern standards, although you have to remember that big commercial jets of that era, such as the 707 and Comet, were equally as narrow. It wasn't until the 747 arrived that the utility of much wider aircraft became obvious. These were retired in 2006, with the heavy lifting being done by the C-5 and the C-17s. Next, we have a Space Shuttle Crew Compartment Trainer number 1 of 3 built to train the astronauts. But first, we'll have a look at something really interesting in the cargo hold. This is a spacecraft P-81, which carried an experimental infrared telescope called Teal Ruby. This was designed to detect the heat of any enemy aircraft crossing the polar region towards the USA. This was to be launched on the Space Shuttle in the 1980s, but following the grounding due to the Challenger accident, this technology rapidly became obsolete by the time the orbiter missions resumed, so that it was then used to test how space equipment age in storage. We'll walk up and have a look at the cockpit of this Space Shuttle orbiter trainer. Crew members would simulate orbital tasks and practice emergencies with the controls which were all identical to the real orbiters. In this example, the forward section of the display is the trainer, while the rest include the payload bay, and the tail was a mock-up to simulate the size of the real thing. And this is a great view of the museum, including the XB-70 and the YF-23. This Boeing X-40A is filmed out of order because I missed it the first time. It's an 85% scale platform to test the aerodynamics and navigation of the X-37 Future Reusable Launch Vehicle, which is essentially an unpiloted space shuttle orbiter. This was dropped 7 times from 1998 and successfully glided down to the planned runway. The X-37 has been in service since 2010, but sadly most of its activities are highly classified, but hopefully I'll be able to film a video around that in 20 or 30 years. This here is a Hexagon KH-9, which was the largest and last US intelligence satellite to return physical film to Earth. These completed 19 missions and imaged 877 million square miles of the Earth's surface up until 1986. They could identify something around 2 feet wide from an altitude of 80 to 100 miles. The 227 kilograms of film would then be sent down to Earth in a re-entry vehicle and then picked up by the Navy. Let's walk into the missile gallery, which is a silo-like structure which stands 140 feet tall and allows us to compare some of the most famous ICBMs. I'll be brief in here as my legs were very sore after all of this walking. We'll turn around and film from up here. First, we have the Boeing LGM-30A Minuteman I-A, which was America's first ICBM powered by solid fuel. This allowed for a much quicker launch time as it was already fueled and ready to go within a minute. Previous ICBMs would take up to 30 minutes to fuel just before the launch. The name comes from a colonial term where farmers would be ready to defend their homes at a moment's notice. Here's a photo of the re-entry vehicle, which would carry the warhead to its destination, and the one on the right has been tested and charred from re-entry through the atmosphere. This green and shorter looking missile is the Minuteman III, which is the current ICBM in service. On the other side of it is the older Titan I, which was the first ICBM, housed in silos and took around 15 minutes to fuel and would then be elevated up to the surface for launch. On the left of that is a W-53 thermonuclear warhead, which went into the next missile, the Titan II, which by the way I have a video walking around the silo in Arizona on my channel. This quickly replaced the Titan I and served from 1963 until 1987. A major improvement was being able to launch it within 60 seconds. Now rather embarrassingly, I've misplaced my notes on the rest of the rockets here, so I can't tell you much more about them, so sorry about that. And coming towards the end of our tour, we'll have a look at some of these aircraft outside. This fellow with the big nose is a Boeing EC-135E Aria, based on the C-135 Stratolifter cargo aircraft. It had a steerable 7-foot antenna dish in that nose and was able to provide mobile tracking and telemetry for the Apollo space program. It was also used to gather other information, including data to verify international treaties and support cruise and ballistic missile tests. This was retired in the year 2000. Next is its brother, the KC-135R Stratotanker. These were delivered to the USAF from 1957 and remain in service, albeit with major upgrades. This R model has the upgraded and larger engines, which were 25% more fuel efficient than the engines they replaced. I mentioned earlier how fighter jets were too fast for prop-driven tankers, therefore this aircraft was the result of that need. It was modified and turned into a commercial airliner, the Boeing 707. Spinning around, and we have a Boeing C-17 Globemaster III, which entered service in 1993. It's extremely versatile, and even though it's very large, it's also capable of operating from rough and small airfields. Through the rear opening doors, it can carry up to 170,000 pounds of cargo, including an M1 Abrams main battle tank. The cargo hold is almost double the width of the C-141 cargo aircraft you saw earlier. This aircraft is a Convair NC-131H total in-flight simulator based on the C-131B transport aircraft. The idea was that this could be used to simulate future aircraft before building a full-scale prototype. It could be configured with two different noses and kept the original cockpit so that the crew could take over and safely land the plane if there was a problem. Vertical fins on the wings generated side forces to simulate cross winds, and this was used to simulate the B-1 bomber, Tacit Blue, B-2, YF-23 and even the C-17 that you saw a moment ago. It was retired in 2008. This is the end of my tour, and I hope you enjoyed it and the part 1 video. If you haven't seen the first half, then please check it out as it really was fascinating. It took a long time to edit, so please comment below if you enjoyed the video and give it a thumbs up. Please check out my channel for many more similar videos, and thanks for watching.